Okay, so let's look at some more examples here. So this one, we're going to write in general form, and so we have to basically find our vertex, our intercepts, and go from there. So first thing I'm going to do is I'm going to change to purple, and then we'll have, what is our vertex? Well, we look over here, we have over 1, 2, up 3. So the vertex is -2, 3. Okay. Now I'm going to use this intercept as one of my points. I need some xy point. And so xy that I'm going to use is going to be 0, 2. Now I'm going to plug all that into the y equals a times x minus h squared plus k. And when I do that, I'm going to have y is 2a 0 minus 2 squared, then plus 3. So 2 equals, here that's going to be a plus 2, and then squared is going to be 4, so it's going to be 4a. And then that's going to be plus 3, so minus 3 minus 3. So -1 equals 4a. So a is equal to -1/4. Okay. So we have a max value, which is what we should be getting because it's a negative. And so if we plug that back in, let's say we use f of x equals, and now we'll have a -1/4 times x. Now minus a minus 2 is going to be plus 2, and that's squared, and then plus 3. Now I need to square that, so it's going to be a -1/4 times x squared plus 4x plus 4, and then plus 3 after that. So now I need to distribute my 1/4 that's negative, so that's -1/4 x squared, and we multiply that, that's going to be just a minus x. Multiply that, that's just going to be -1 plus 3. And so then f of x is equal to -1/4 x squared minus x plus 2. And so that's going to be my general form. Now, if we needed the standard form, we have that as well. Okay. And so that's how I would get to my general form based on my parabola that we are given here. All right, so now we want to go ahead and find our minimum, our maximum, and the axis of symmetry and all that good stuff here. And so when we do that, actually, do I have another one up there? Oh, all right. So I think I missed a problem here. That's okay. I was going to do a different problem, but we'll move on to the next page. All right. And so this was the one we're going to do. And what we're going to have to do is, find our intercepts, find our domains and ranges, all that good stuff. So the first thing that's easy, we can find f of 0 like we did in class. So that's 0, and that's equal to 3. So our y-intercept is 0, 3. Now, if we wanted to, we could go ahead and say, well, our domain is equal to all real numbers, and our range is equal to, well, now we have a negative here, so we know it's going to be a maximum, and so the being a maximum, we know it's going to have something here, and it's going to go from -infinity. Maybe I better make the negative a little closer here. So it's going to go from the -infinity up to whatever we find for our k value. And the way we find our k value is we plug in, find h first. So it's going to be a minus b, so it's a -2 over 2 times a -1/3. All right. So if we multiply here and take the reciprocal, uh, uh, yeah, it's -1. Okay. Okay, yeah, so that's going to be a plus, that's going to be minus, that comes on top over that too, so that becomes a 3, so it's -3. All right, so now we plug in -3 into our equation here to solve for k. So -1/3 times a -3 squared minus 2 times -3 plus 3. And so that's going to be a -1/3 times 9 plus 6 plus 3. So that's going to give me a minus 3 plus 3 is going to be 0. And then we just have 6 as far as our k goes. And so that is, oops, 6. So that's what we're going to have for our upper limit for the range. And we get a vertex is a minus 3, 6. We have an axis of symmetry, and that's going to be x equals a minus 3. And let's see, what else do we have? That's about it. Now, if I look at this, I don't think I want to factor that. And so because I don't want to factor that, then I'm going to do one of the two methods. I'm going to first write it in standard form and solve it that way. And then second, I'm going to use the quadratic formula. So if I first put it in the standard form and set it equal to 0, I'm going to have 0 equals minus 1 over 3 times, and then we'll have x, and then our h is that, so it's going to be plus 3 squared, and then we'll have our k is plus 6. Okay. Now I need to solve for x, so subtract 6, subtract 6. So minus 6 equals a minus 1/3 times x plus 3 squared. So now I'm going to multiply by a negative 3. I'm going to multiply by a negative 3. So 18 is equal to x plus 3, the quantity squared. Now, to solve for this, I'm going to have to take the square root of that side, and I'll take plus or minus the square root of this. Now, 18 is 2 times 9. Square root of 9 is 3, so I'll have plus or minus 3. Square root of 2 is equal to x plus 3. So if I subtract 3 from both sides, I'll have x equals a minus 3 plus or minus 3 square root of 2. And with that, I have my two intercepts, so a minus 3 plus 3 square root of 2 comma 0. And I have minus 3 minus 3 square root of 2 comma 0. Okay, so those are my x-intercepts. So I've got now my x-intercepts. My y-intercept is that one. I've got my domain and I've got my range. I've got my axis to symmetry. And then I've got here, it's going to be a max is 6 at x equals a negative 3. So I have all the items that we needed for this problem. All right, so let's look at some more here. Again, we're solving for over the complex numbers. Now, this one is a little different than one we did in class 1. In class had x squared equals negative 25. This says x squared plus 36 equals 0. So the way it's set up, we would really just say, okay, well, we have x equals a minus b, which is 0, plus or minus the square root of 0 squared minus 4 times a times c all over, and then 2 times a. And so that's going to be basically drops out. We have plus or minus the square root of, and then 4 times 36 is 144. So negative 144, and that's all over 2. Now the square root of 144 is 12. Square root of negative 1 is I. So that's going to be plus or minus 12i over 2. So plus or minus 6i. Now we could have also done it and said, well, x squared plus 36 equals 0. Subtract 36 from both sides. So x squared equals negative 36. And then take the square root of both sides. And when I do that, x is equal to plus or minus, now we just have 6i after we take the square root of a negative 36. So we get the same answer both ways. The first way is going to be the one that you use more often because a lot of times you're going to have, the trinomials instead of a simple x squared equals some value. All right, so the next one, let's go ahead and do again with the quadratic formula only. So it's going to be minus a minus 8 plus or minus square root of, and then we have a 8 squared 64 minus 4 times a times c, and all over 2 times a. All right, so that's going to be 25 times 4 is 100, and that's going to be, so that's going to give me 8 plus or minus the square root of negative 36 over 10. And so this is going to be 6i, so that's going to give me 8 over 10 plus or minus 6i over 10. Now, if we reduce, 2 will go in here 4, that'll go in 5, plus or minus 2 will go in here 3i over 5. And that will be my values for x. So I'll have x is 4/5 plus 3i over 5 and 4/5 minus 3i over 5. Okay. And again, it's just using quadratic formula, and then they're really usually nice and give you things that you can take perfect square roots of. All right, this one's again like the first one. We just plug in values. So we had our y equals a times x minus h squared plus k. Y, here's 1 equals a times x, which is 10, minus h, which is 3 squared, and then plus k, which is 2. Okay. So 1 equals 10 minus 3 is 7 squared, so that's going to be 49a, and then plus 2, so subtract 2. So that's going to be a minus 1 equals 49a, so a equals a minus 1 over 49. So not too nice of a number because we're going to have to start multiplying and adding all these things in. So let's start up here. And so we say, well, I don't know, maybe we want to use f of x, maybe, I don't know. F of x equals, and so our a is negative 1 over 49 times x minus 3, the quantity squared, plus 2. Now that's our standard form, but we want to get to the general form. So what we have to do is we have to square this. And so that's going to be minus 1 over 49 times, that's going to give us x squared. Then that's going to give us minus 6x. That's going to give us plus 9 plus 2. Now if we distribute the negative 1 over 49, then that's going to be plus 6x over 49. And then that's going to give us a minus 9 over 49, then plus 2. All right, so now we have to take 2 times 49, so I have to multiply that by this. And so that's minus 1 over 49x squared, and then plus 6 over 49x. And that's going to be 2 times 49, which is, and then minus 9. So that's going to be 89 over 49. And so then that would be our general form of the function. Okay. And again, nothing hard. In this case, we had a little bit more to do because we had fractions that we had to worry about, but it wasn't as bad as it could be. All right, so some application problems. It says, among all the pairs of numbers whose sum is 6, find the pair with the largest product. And what is that product? All right, so this one you could do without even doing any quadratics or anything else. You could just start multiplying things together, but the key is you might end up with, you have decimals or something like that. So you can't just assume that it's going to be the ones that are obvious. And so what we're going to say is we're going to say x equal our first number. Okay. Well, if the sum of them is 6, then 6 minus x is going to be our second number. Okay. Now, what we need to do is we need to find the product. And so, I don't know, we can again, just because f of x is a good thing, we could take 6 minus x times x, and that's going to give us 6x minus x squared, or if we rewrite it, minus x squared plus 6x. Okay, so that's going to be our function. It's a max because we have the negative here, so that's good to know. So now we just have to find our h, which is going to be a minus b, which is 6, over 2 times a, which is a negative 1. So 6 divided by 2 is 3. It's positive because we have negative over negative. And so now if we wanted our k, what's going to be is going to be minus 3 squared plus 6 times 3. So that's going to be a minus 9 plus 18. So that's going to give us a 9. And so what does this tell us? Well, this tells us x is equal to 3 because that's our x part. And so 6 minus x, well, that's going to be 3 as well. And we know that if we're taking the product, 3 times 3 is 9. Well, guess what? We also found that it's 9 here with the product. And so our product is equal to k, which is equal to 9. Or if we just took the 3 times the 3, once we found our two numbers, we also get the product being 9. All right, so one last one I think we have here, and that's going to be with trees. And so it says a farmer finds that if she plants 75 trees per acre, each tree will yield 20 bushels of fruit. She estimates that for each additional tree planted per acre, not above 75, but just each tree she plants per acre, the yield of each tree will decrease by 3 bushels. How many trees should she plant per acre to maximize her harvest? All right, so we have to set some values here. So let's say x is equal to the number of additional trees. Okay. And so with that in mind, then we could say, okay, well, the number of trees is going to be basically 75 plus x when we get done. And the number of bushels is going to be equal to the total 20 minus 3 times x, because every tree extra we add, it decreases by 3 bushels. So 20 minus 3x. And so our function of x, again, f of x, is going to be the number of trees times the number of bushels. So if we just had the 75 times 20, that would be the given, but we want to find out what the maximum would be. So what we're going to do is we're going to take 75 plus x times 20 minus 3x, and we're going to get our quadratic function. All right, so 75 times 20 is going to be 1500. 75 times 3 is going to be minus 225x. 20 times x is plus 20x. X times that's going to give us minus 3x squared. Now, if we write it in the standard form, decreasing powers, that's a minus 3x squared. Subtract off 20, that's a minus 205x plus 1500. Now, that's going to be our function. And so now we can say, okay, well, what is h? Well, h is equal to minus b, so it's a minus 205 divided by 2 times a, which is a minus 3. So that's a positive in the numerator and negative in the denominator, so it's going to be a negative value, and that's going to give us our x. So x is going to be negative, so we're going to subtract off some trees from that 75. And 205 divided by 6 is 205 divided by 6, 34.1666. So it's a negative 34.1666. That keeps repeating. So if we use whole trees, because we can't use a half a tree or part of a tree, that's about a negative 34 trees. Because if we make it more, that'd be too much. So we'll just say it's negative 34 trees. Okay. Well, what does that give us for k? Well, k is going to be, now we plug in everything here, so it's a minus 3 times negative 34 squared minus 205 times negative 34, well, 34, and then plus our 1500. And so if we plug all that in, so we have a negative 3 times negative 34 squared minus 205 times negative 34 plus 1500. So that's 5002, and that's going to be trees. So this is going to be, actually that's not trees, that's bushels, sorry. That first one was trees. I'm writing wrong thing. So this is trees, and this is bushels. Okay. So going back to our original, if x is the number of additional trees, we have to subtract off 34. So then the number of trees is really 75 minus 34, which is going to be 41 trees total. And our bushels is going to be 20 minus 3 times a negative 34. And so that's actually going to be a positive. So 20 plus 3 times 34. So that's going to be 122 bushels. And if we take 122 times 41, we get 5,002. So our total bushels is 41 times 122, and that's equal to 5,002 bushels. And that's what we found down here for our K. So our H was what we needed to do the number of additional trees. So we actually had to do a subtraction to get to the number of trees total, which is 41. And but all that was included into here. So we have 41 trees total, 122 bushels per tree for a total of 5,002 bushels. And we found that with our K, we knew it was going to be 5,002 bushels, and we had to take that one and add it to the 75 to get the total number of trees. All right. I think that's all I have for the additional video. So hopefully that will help you on some additional, especially application type problems.